Hey class, Mr. Hanji here. For today's video, we're going to be taking a look at section 2.4, which is going to be talking about creating and solving inequalities. Now, inequalities, just to kind of refresh your memory, is going to deal with a less than, greater than, less than or equal to, or greater than or equal to sign. So we're going to go through and talk about how we solve these and how to go through and create inequalities for different situations. Now, what we are doing today is just like solving equations. It's just that there's a less than or greater than sign involved in our problems. So it's something to be aware of, that it's going to look and feel a little bit different, but it is the same idea that we have been talking about with solving equations. Alright, for today we only have one learning goal, and our first learning goal is you will be able to write and solve an inequality for a real-world situation. So we're going to go through and set these up, talk about what they look like, and how to solve them. Alright, so I've kind of gone through and mentioned what an inequality is. An inequality is a statement that compares two expressions that are not strictly equal by using one of the following signs. Now, we're not really going to use the is not equal to sign, but we will use the is less than or equal to, greater than or equal to. So those are going to be the ones that we go through and use for this, and that we will use on our stuff for today. Alright, now before we kind of jump in, there is a little bit of terminology that isn't listed here that is helpful to know. Something like this. You have probably seen a sign at an amusement park saying something like, you must be at least 48 inches tall to ride this ride. This statement could be written as h is greater than or equal to 48 inches. H is going to represent a person's height, so the person needs to be more than 48 inches, or they can be 48. Now, something that when you're going through and dealing with problems, the idea of at least, no more than, can be a bit confusing. So it is helpful to kind of have an idea of what each of those mean. Whenever we talk about the statement no more than, no more than is going to refer to is less than or equal to. So when we get to story problems and you're reading a situation where it says they can have no more than 5, that's when you need to use the less than or equal to. Now, we just talked about the other one I want to highlight, which is at least. So for this one, when we talk about at least, that refers to is greater than or equal to. That is just something helpful to kind of keep in mind and just keep near you. I would definitely and highly suggest that you kind of have the completed notes up, because I have this written in. So that way you can remember that and keep that at access, or just make a note on a piece of paper or on a sticky note. Alright, so before we jump into solving, so far we have talked about the addition property of equality, subtraction, multiplication, and division. There is one more that we are going to use today that you've likely seen before, but we are just going to review it, and that is the distributive property. So the distributive property states if A, B, and C are real numbers, then A times the sum of B plus C equals AB plus AC. So if you remember back to when you've talked about the distributive property, all that means is you distribute or multiply A to both parts. So we do A times B and then A times C, and that's where AB plus AC comes from. So distributive property is something we're going to use in our problems today, and just something to be aware of. Alright, so with that said, let's go ahead and get into some solving for today and underway with our work for today. Alright, example 1 is going to have us go through and solve each of these inequalities for x. Now, before we kind of get through and solve, something I want to highlight. The inequality must be reversed, so the sign must be reversed when you multiply or divide both sides of the inequality by a negative number. So whenever you multiply or divide a number that is negative to both sides of the inequality, you have to reverse or flip the sign. So if it's less than or equal to, it then needs to become greater than or equal to. If it's less than, it becomes greater than, less than, and so on. So whenever you multiply or divide to both sides, not by distributing, not your end result, it's when you multiply to both sides is when you flip. All right, so let's take a look at example 1a. So it talks about 5 plus 5 times x plus 4 is less than or equal to 20. So we need to go through and solve this for x. Now, usually when we have gone through and done these problems, okay, we've taken PEMDAS and we've reversed the order, meaning we add or subtract, multiply or divide, and then deal with exponents or parentheses. Well, this is where I'm going to tell you that it's going to be helpful if we distribute and then combine like terms before we do all this for our problems today. So remember to distribute and combine like terms as we go through these problems before you start this whole process. Okay, I like to try to get rid of the parentheses before having to deal with them. All right, so if we look at example 1a, so I mentioned that it's helpful to distribute before we start anything. So we're going to go ahead and distribute the 5 to both parts. We leave the 5 out in front, so it's 5 plus. And then it's 5 times x, so 5x. And then 5 times a positive 4, which is going to give us plus 20. And then this is less than or equal to 20. Now, you can go ahead and just solve from there if you would like. It will work just fine. I suggest, though, before we keep moving on, that we combine like terms. So we distribute, then we combine like terms. So when we combine like terms, okay, I have a positive 5 and a positive 20 on the left. If I combine them, 5 plus 20 is 25. So I end up with 5x plus 25 is less than or equal to 20. All right, now you can go through and do your reverse order of operations to solve. So that means we would subtract 25 and then divide by 5, like we're used to with solving equations. So we're going to go ahead and do that right now. So we subtract 25, and that cancels out on the left. So we're left with 5x is less than or equal to negative 5. And then I need to divide 5 to both sides. So the 5's cancel out on the left, and I get x and a negative 1 on the right. Now, in terms of our sign, you need to ask yourself, does it stay the same or do I need to flip it? Well, if we look at this problem, okay, I divided by a positive 5. Yes, a negative 5 was involved. It's what was being divided. But because I divided by a positive 5, that means my sign stays the same. So then I get x is less than or equal to negative 1. Now, in case graphing comes up, just in case, I just want to address it. I'm not going to draw a whole number line here. It's something you might have seen before, so if I start at negative 1 is my point, because this has an equal to sign on it, because it's less than or equal to, anytime you have an equal to sign, you need to have a solid closed dot, and then this is going to go to the left. Okay, so that means any numbers that are less than or equal to negative 1. So in this case, if we think about that, okay, any numbers less than negative 1, so like negative 2 and so on, are numbers that would work for this inequality. So that is how you go through and solve for this one. And That is our answer for example 1A. All right, so continuing on through our stuff for today, part B is going to be following the same idea where you want to go through and distribute the 4/3 first. So you would do 4/3 times 6x, 4/3 times 9. See if you can combine any like terms, and then start adding or subtracting, multiplying or dividing. If you would like guidance on this, you can always take a look at my completed notes. If you want me to explain this later, by all means, I'll be more than happy to do that for you. To kind of give you an idea of what you're going to end up with. Okay, at the end, you should end up with x is less than a -1. So when you go through and solve this all the way through, that's what you get. In the graph for this, okay, if we use my same starting point, because there's no equal to sign on the bottom, it's going to be an open dot, and because it's less than, it goes to the left. All right, so with that said, we're going to go ahead and move on to the other parts for example 1. I am going to take a look at C and B, or not B, sorry, D. I'm going to take a look at C and D for the reasons that each of them provides a situation that is helpful to talk about. C has 2 sets of parentheses, and D is going to present a situation that we need to address. So, with that said, if we take a look at C, I have 5 times 3 minus x minus 4 times 2 minus 3x is greater than 2. So, like I said this whole time, first thing to do is go through and distribute. Well, we have 2 sets of parentheses. I'm going to address one at a time before we kind of jump into all of it. So let's go ahead and focus on distributing the 5 first. So 5 is out in front of this set, so it multiplies into both parts. So we're going to have 5 times 3, which is 15, and then 5 times, this is considered a negative x, so you kind of keep the sign with it here. So 5 times negative x is going to give us a negative 5x. Now for the second set of parentheses, okay, again, we have to keep the sign with it, so we're going to consider this a -4. So we're going to do a -4 times 2 and a -4 times a -3x. So -4 times 2 is going to give us -8, and -4 times a -3x is going to give us plus 12x, and that is all greater than 2. All right, next we need to go through and combine like terms. Okay, so the like terms that I have are 15 and a -8, and then I have a -5x and a positive 12x. So if I go through and simplify, I'm going to end up with a 7 plus 7x is greater than 2. Okay, 15 minus 8 gives me 7, and -5x plus 12x gives me a 7x. And then 2 stays the same. From here, you just need to go through and solve moving forward. So you would subtract the 7 and then divide by 7, which is going to give us x is greater than -5/7. And because this is a more than sign, okay, if I had my graph, so -5/7, it's an open dot that goes to the right. All right, so next let's take a look at D. So D is going to have a negative 2 times 1/4 x plus 2, which is greater than or equal to 5. So we're going to go through and distribute the negative 2. So negative 2 times 1/4. Okay, if you're uncertain of what that's going to be, by all means you can use your calculator. So we're going to do negative 2 times, and then parenthesis 1/4. And then we're going to end up with negative 0.5. So we get negative 0.5x. And then if we do negative 2 times a positive 2, we get minus 4 is greater than or equal to 5. So then we just go through and solve. There's no combining like terms in this problem, so I can just go ahead and solve. So we're going to add the 4. So we'll get negative 0.5x is greater than or equal to 9. And then I need to divide by a negative 0.5. So that cancels out on the left. And on the right, if I do 9 divided by negative 0.5, okay, we end up with negative 18. So we get x and then negative 18. Now the question becomes, does my sign stay the same or does it change? Well, I divided by a negative 0.5 to both sides. Because I divided by a negative, instead of having this as a greater than or equal to, my sign flips and will change color to become less than or equal to. And then that is your answer for this inequality. So my sign flips because I multiplied by a negative, and it changes that. It's just a property of inequalities. And then I now have x is less than or equal to negative 18. So a graph of that would be a closed dot at negative 18 that goes to the left. All right, so that is how we're going to go through and do example 1, and that's it for solving inequalities like this. Everything from here on is really just kind of more practice of that. There is a story problem related to example 1 that I do want to take a look at in setting up. I'll by all means let you go through and solve it, so that way we can save some time. And then example 2 is going to have variables on both sides, so it's a good one to kind of look at. All right, so for E, we're going to take a look. This is still continuing example 1. For E, we have Trina is buying 12 shirts for the drama club. She will choose a style for the blank shirts and then pay an additional $2.75 for each shirt to have the club logo. If Trina cannot spend more than $99, how much can she spend on each blank shirt? Write and solve an inequality to find the possible cost of each blank shirt. So she's buying 12 shirts, and then she's paying an additional charge of $2.75 for each shirt to have the club logo. And then she cannot spend more than $99. So if we're going to set this up, okay, we have 12 shirts that she is buying, and it's a certain amount per shirt plus an additional $2.75, and she cannot spend more than $99. So we're going to start with the 12, and then it is the cost of a shirt plus $2.75 for each shirt to have a logo put on. So it's the cost of the shirt, X, plus an additional $12.75 per shirt to have the logo put on. And then when we talk about no more than, okay, if you reference on the first page what no more than means, based off what I wrote as a hint, it means we're going to use the less than or equal to sign and then 99. So the reason I'm using the less than or equal to sign is because on the front side I told you guys no more than relates to is less than or equal to. So again, it is helpful, and keep that in mind as you go through and do this. So from here, you're just going to go through and solve normally, where you're going to go through and distribute the 12 to multiply it to the x and the 2.75, and then add or subtract, multiply or divide, and you should get your answer for your inequality. So I will leave the rest of this for you to go through and solve, since we've already done 3 together. You can always take a look at my completed notes or ask me to run through it next time you see me. Alright, so example 2, we are going to step it up a notch, where we have variables on both sides. So we're still going through and solving inequalities. It's just when we go through and solve these, there's a variable on both sides. So on the other side, when I talked about example 1, I talked about the fact that you needed to distribute, combine like terms, and then you could do reverse order of operations. For these ones, what I would suggest you do is you go through and distribute, combine like terms, move the variable to one side, then you can do reverse order of operations. Okay, if you look at these problems, okay, we have x on both sides, meaning we need to address that and move it to one side. So with that said, let's go ahead and get started on our work for example 2a. So we have x plus 1 is greater than a negative 5 times 7 minus 2x. Again, we need to deal with parentheses first. So we're going to go through and take this negative 5 and distribute it to both parts. So on the left, x plus 1 stays the same. On the right, we're going to have negative 5 times 7, which gives us a negative 35. And then a negative 5 times, remember we're going to include that sign, so it's a negative 2x. Negative 5 times negative 2 is going to give us a positive 10x. Alright, so we now have x plus 1 is greater than negative 35 plus 10x. Now, this is where it changes, okay? I need to go through and get the variable on one side, okay? I have an x here and an x here. I either need to have it on the left or to have it on the right. Doesn't matter which side you move it to. Some teachers will tell you to always move it to the left. Some teachers will always tell you to move the smaller x to the other side, or try to get it to where you have a positive x. Okay, I like to try to move it to where I can get a positive x, because this is a 1x right here, and this is a 10x, a positive 10x. I'm actually going to move this x to the right, so we're going to subtract 1x to both sides. So the 1x cancels out on the left, so I'm left with 1 is greater than a negative 35 plus 9x. And then you just go through and solve per normal. So I would add 35. So then we get 36 is greater than a 9x. And then when we divide by 9, we get 4 and then x. And then because I divided by a positive 9, that means my sign stays the same. So we have 4 is greater than x. Now, sometimes the homework site or some teachers prefer to have x in front. So to do that, we just flip everything around. So it would be x, and then instead of greater than, it's less than 4. So when you get to these problems that have variables on both sides, go through and distribute first, get rid of your parentheses, combine like terms, move the variable to one side, and then you can go through and solve per normal. So it's distribute, combine like terms, and then move the variable to one side. So you have three things you need to do before you can undo addition, subtraction, and then multiplication and division. All right, I'm going to leave B for you. You can take a look at my completed notes for how I do this one. I just want to kind of save time in the video. To kind of get you guys set up though for this one, again, you would want to go through and distribute the 2 first. So the left side would stay the same. We get 2 times 10, which is 20. 2 times 2x, which is going to be 4x. And then we have plus 3. Okay, I can't combine anything on the left side, but I can combine my 20 and my 3 on the right. So we get negative 5 minus 3x is greater than or equal to 4x plus 23. So from here you would have to move the variable to one side. Okay, I have a negative 3x and a positive 4x. Anytime you have a negative or you're subtracting with an x, I always like to go through and use that one and add it to the other side because I like to deal with positives and not negatives. So I would add the 3x because it's negative, which is going to give me a negative 5 is greater than or equal to 7x plus 23. I will leave this part for you to kind of go through and finish solving. Again, you can always take a look at my completed notes to see what I get for the final answer. So I will leave that for you to finish solving. All right, now example 2, there are a few more parts to example 2. I do want to take a look at a story problem, and then I'm going to take a look at one of our last sets. So the school band will sell pizzas to raise money for new uniforms. The supplier charges $100 plus $4 per pizza. So this is what the supplier charges. And then band members will sell the pizzas for $7 each. Write and solve an inequality for how many pizzas the band members would have to sell to make a profit. So we're going to use P as our variable for number of pizzas. And then we'll go through and set up our problem. So the supplier is charging $100 plus $4 per pizza. So the supplier is $100 plus $4 per pizza. And then the band is selling the pizzas for $7 each. So 7p. Now, this is just like the equations that we talked about in section 2.2, where you would set them equal to each other. But because we're dealing with inequalities, we need to have this different. So we're going to have 100 plus 4p. And then 7p is going to be on the other side. Now, we need to have an inequality, find out for the band members to make a profit. So we want the band to make a profit, so we want this to be larger to make it a profit. So that means I need this to be greater than. So it's 100 plus 4p is less than 7p because I need 7p to be larger. So when you go through and solve this, okay, you would subtract the 4p, and we get 100 is less than 3p. And when we divide, we get 33.3 repeating. Now, you cannot have a partial pizza that the band is selling. They're selling the whole pizza. So the next largest would be 34. Because we want to make a profit, not less, we need to go up. So that means they need to sell 34 pizzas to make a profit. Okay, there's only 2 parts remaining for this. that we have talked about for today. Parts D and E here are going to carry the same idea for what we have talked about with example 2, where you have a variable on both sides. It's just, in this case, you have a parenthesis on both sides as well. So you have to go through and distribute both sides, as well as move the variable to one side. Now, as much as intimidating as D looks, I'm actually going to leave this one for you to do. You can look at my completed notes to go through and do it. Just kind of as a reminder, when you go through and distribute, okay, you have to multiply by the negative in front. If it's subtracting, so that means I need to multiply by a -2 to both parts and a -3 to both parts to go through and solve that. So I'll start this and then you can finish. But 6x stays the same. And then we're going to do -2 times x and a -2 times 2. So that gives us -2x minus 4 is greater than. 2 stays the same. And then it's -3 times x and -3 times a +3. So it's a -3x minus 9. Okay, combine like terms on both sides, move the variable to one side, move the numbers to the other, and then you should be good to go. All right, so let's take a look at E. This is where I want to wrap up for today. So E, we have 8 times 1/4 x minus 3 plus 24 is less than 4 times x plus 5. So we're going to go through and distribute the 8 to both parts. So 8 times 1/4, just in case you guys are struggling with what that is or you don't believe me, 8 times 1/4 is going to give us 2. So we're going to cancel out the fraction. We get 2x minus, well, 8 times 3 is 24. Plus 24 is less than 4 times x, and then 4 times 5. So we get 4x plus 20. Now, if I look at combining like terms, I have a -24 and a +24. Well, -24 plus 24 is 0. So I end up with 2x is less than 4x plus 20. Because these cancel out. I need to move the variable to one side because I just have the variable on the left here. I'm going to move the 4x to the left. So 2 minus 4 is going to give us a -2x. And then that's going to be less than 20. I have to divide by -2. So that cancels out on the left. And then 20 divided by -2 is -10. Now, because we divided by a negative here, that means my sign flips. So instead of less than, it becomes greater than. And then that is your answer for example 2E. All right, so with that said, that is your lesson for section 2.4. Treat this like solving equations. I know there's a few increased steps. By all means, next time you see me, whether it's in Zoom or in class, please do ask for help if you need help. Okay, I'm more than happy to help you walk through these, kind of get you through a step if you're struggling. Look at the examples, look at my completed notes for guidance. But otherwise, that is your lesson for section 2.4 on creating and solving inequalities. And thank you for listening, and I hope you have a great day. All right, bye.